by 7, then we have 2 days left. So it will come to me.
What?
Because 366 by 7 is 52 weeks and 2 extra days, right?
Yes.
So the two of these pair, and if we make pairs, and two of those pairs would have a Sunday. So it's 2 by 7. Is that wrong?
No. No, I am not getting your logic actually.
By 7, then we have 2 days left. So it will come to me.
What?
Because 366 by 7 is 52 weeks and 2 extra days, right?
Yes.
So the two of these pair, and if we make pairs, and two of those pairs would have a Sunday. So it's 2 by 7. Is that wrong?
No. No, I am not getting your logic actually. 2 days are there, right? 2 extra days. Now those 2 days
Yeah,
could be any.
and
Let's say Monday, Sunday, Monday, Monday. No, not Monday, Monday. Can it be Monday, Monday?
no.
Okay.
It can be Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday.
Okay. Yeah. So basically, the order here is important, right? Like one thing would happen that Sunday is coming before or after, basically on the first day itself or the second day. So 2 by 7. Correct.
Yeah.
Okay. So what is the answer that you're getting? That is 1 by 4 into you have to multiply. So 2 by 7 plus 3 by 4 into 1 by 7. That is your answer. Which is how much? 5 by 28. This is your answer. Now let's solve for exactly 52 Sundays. Okay. Exactly 52 Sundays if we want. So firstly, years. If it's a leap year, not a leap year, probability of a leap year is 1 by 4. This is 3 by 4. Okay. Then we want 52 Sundays eventually. This is how you make the tree diagram. If it's not a leap year, so how could you have 52 Sundays? So basically, you should not have a Sunday. So like it's 6 by 7. And for this, it is what? It is 5 by 7. So the answer is 3 by 4 into 6 by 7 plus 1 by 4 into 5 by 7. Now this is how much?
18 by 28 plus 5 by 28.
23 by 28.
Yeah.
Which is basically 1 minus this.
Yeah.
Okay. So this is your total probability actually. Okay, now the questions here are very famous. So let's say you have 3 bags. Okay. Bag 1 contains 2 white balls and 5 black balls. Bag 2 contains 3 white balls and 4 black balls. And bag 3 contains 5 white balls and 1 black ball. A ball is drawn. A ball is drawn from one of the bags. Probability of getting a white ball is what? If selection of bags is equally likely. First case and the second case is probability of selection of bag C is proportional to wait, what is this? Wait, probability of selection of bag is proportional to I. Basically, we can say we have 3 bags, right? So let's say bag I.
Your voice is breaking.
Hello, am I audible? Hello, Anant.
Yeah, I can hear you, but your voice is breaking.
Okay,
Give
so
me a
see, I'm
second, I'll
telling.
just change my internet.
Okay. Hello.
Yeah, now I can hear you.
Okay. So this is a question. You can try this as a homework question.
You zoom
Uh,
out a bit.
First part is easy. Second part is just saying that probability of selection of bag I is proportional to I. So there are three bags. So what is going to be the probability of selection of bag 3? So that's going to be like basically proportional to 3. So you'll have to remove this. We'll solve this later. First, let's say
I
we move
can
on to
try
the.
if you would like.
Okay, you can try them.
Like just roughly, if you have B1 equal to, okay, B1, B2, B3, we have 2, 3, 5, 5, 4, 1, and 7, 7, 6. Okay. The probability of drawing from each bag is the same, right?
Yeah, for the first case.
Yeah. So using PW equal to PB1 into PW by PB1 plus, we're using that only, right? 1 by 3 divided by 2 by 7 plus 1 by 3 into 3 by 7 plus 1 by 3 into 5 by 6. So 2 by 21, 3 by 21, and 5 by 18. So 5 by 21 plus 5 by 18. That's around 30 plus 35 by 1 by 20, 126. That's around 65 by 126, I think.
Okay.
Is that fine?
Okay, you can solve the second part.
Yeah. Probability of selection of bag I is directly proportional to I. So that means PB1 is K. If I take it as K, PB2 is 2K, 3K. So sum of probabilities must be 1. So 6K equal to 1. So K equal to 1 by 6. So it's 1 by 6, 2 by 6, and 3 by 6. So then for white ball, it's 1 by 6 into 2 by 7. So that's how much? 2 by 42 plus 1 by 3 into 3 by 7 plus by 21 plus 1 by 2 into 5 by 6. That's 5 by 12. So 1 by 21, 3 by 21, 5 by 12. So 4 by 21 plus 5 by 12. 16 plus 35? Yeah. 16 plus 35 by 84. So that's 51 by 84, which is, I think I can reduce this. 17 by 28.
Okay.
Is that fine?
So unfortunately, both of them are wrong.
Okay.
Okay, let's solve. Um, you have three bags. What is the see? You want white ball. What is the probability that you are getting a white ball? So from bag one, it is what 2 by 7.
2 by 7, 3 by 7, and 5 by 6.
Okay, they are like 1 by 3, 1 by 3.
Yeah. So the probability of getting a white ball is 1 by 3 into 2 by 7. I don't know where do you go wrong then? 2 by 21 plus 3 by 21 plus 5 by 18. This is exactly what I got.
Okay, can you like again try to sum it up? Maybe there could be some mistake.
I mean, isn't it 30 by 126 plus 35 by 126?
Wait, 5 white plus 1 black. Right. Okay, this is correct. My bad. Sorry. Now about this also, that's correct. Okay, ignore that.
It's correct,
So
right?
yeah. So actually, what happened here was I did a mistake. I had to write 2 here, but you solved for 1, so that's correct.
Oh, okay.
I wanted to make the denominators equal. Sorry. Now something about
Mm.
Bayes theorem. Bayes theorem is very similar to this total probability theorem. This is also known as reverse probability theorem because here something has already happened. So now, what is the probability that before happening this some is thing happened? So something like that. Okay. Also, I think the spelling is spelling is correct. Reverse order. Okay. Let's say you're having bag one as 3 white and 5 red balls. Bag two as 4 white and 6 red balls. So the question is, if a ball is drawn from one of the bags and is found to be red, okay, then find the probability that it is drawn from bag two. So now they're saying that it is red. Now, what is the probability that it was drawn from bag two? So again, same tree diagram we would make. So we have bags, right? Bag one, bag two. We are eventually finding a red ball. Okay. Equally likely, conventional we take equally likely. So bag 1 a red ball is how much? 5 by 8. And bag 2 is how much? 6 by 10. Correct? Okay, now actually what happens is they're asking for bag 2. So we weigh the probability of bag 2 with respect to total. And total, I mean total probability. How would you write the total probability here? 1 by 2 into 5 by 8 plus 1 by 2 into 6 by 10. Correct. This comes in the denominator. In the numerator comes this one, basically with respect to bag 2. So with respect to bag 2 is this part. So that's 1 by 2 into 6 by 10. This is your base theorem. Okay. Now, let's solve another question. Okay, let's say a real estate man has 10 master keys to open several houses. Only one master key works on any lock, and 40% of the houses in his possession are kept unlocked. While visiting the house, he randomly picked 4 keys and left. Given that, so whenever they like use this word given that, so that means something has already happened, with respect to something else happening. So definitely you have to use base theorem here. So given that he is able to enter the house, what is the probability that it was logged? Good question, you can try this. As a hint, I can say that in the tree diagram that you make, you can consider houses in the first level, then in the second level, it could be logged or unlogged, and eventually you have to let the man enter. So then that way you can solve for probabilities.
Practice maths regularly, but still don't improve. Because the same mistakes keep repeating, and no one tracks them. In exams, this turns into confusion and blank moments. With one-to-one mentoring, every mistake is corrected, and real improvement begins.